Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're going to see maximum and minimum sums of at most K subsequences. Now, if you don't know what a subsequence is, they have given what a subsequence is. Subsequence is nothing but in the order itself choosing some elements, skipping some elements. That's what a subsequence is. For example, for this array, the subsequence can be 1, 3, another can be 2, another can be 2, 3, but it cannot be 3, 1. No, it should be in the same order, but maybe skipping some elements. That's what a subsequence is. Now, the actual question is that you are given an integer array nums, as you can see, nums, and an integer k, positive integer k. I have to return the sum of maximum and minimum elements of all subsequences of nums with at most k elements. Okay, so let's break it down. What I want, I primarily require minimum and maximum element easily, or I should say fast. Another thing is that I'm not concerned about the initial order because I myself have to choose some elements and I can choose at most k elements. So that is also, again, even if you might argue, Aryan, you are concerned about the order because they are referring subsequence. Yes, I am concerned about the order. Even if this array, let's say, if this array would have been 3 to 1, if I take a subsequence, let's say if I take a subsequence which is 3, 1, primarily I am saying I'm only concerned about the max in this subsequence and min in this subsequence. That's it. For me, that is the only primary concern and not the actual order in between. That is the reason if I want min max and I am also not concerned about the order per se here, thus I can simply sort this specific sequence of nums and I will achieve a sorted sequence of nums. Now you might argue, Aryan, how is this useful? This is pretty much very useful. How? Let's see. Now, right now I have three elements, but imagine I have more. I have, let's say, these elements 1, 2, 3, 4, 5, 6, 7. Let's say I have 7 elements here. Now, as I am on any specific index, again, I have always told in every past videos also, whenever you want to come to an answer, don't start from the very scratch. No, this is while you are actually learning from the very basics. Let's say if you're learning greedy, deep from the very basics, then you should do it. Else, go to a random location. Here, let's say any index I. Here the index, let's say, will be 2 because if I just put the indexes 0, 1, 2, 3, 4, 5, 6. Again, no matter what the value here is, but let's say I am at this location. If I'm at this location, now my primary task is that I have to make subsequences, but also the subsequence can be, okay, the subsequence will have one element, it can have two elements, it can have three elements, or it can have k elements, which means the size of the subsequence can be 1, 2, 3 up till k. This is what I have to try. So can't I simply say that, okay, this is the corresponding element? Obviously, I will now, rather than building a subsequence, which obviously can be exponential in our case, I will simply say that forget about all these possible, all these possible size of subsequences. Let's take any random size. Let's say the size of 3. Again, I am taking, let's say, one size of 3. I am only concerned about the answer, and the answer is the sum of maximum and minimum, which means in the size of 3, how many times this index 2 will come as the minimum element and how many times it will come as the maximum element. That is now my primary goal here. Again, like you should remember that I have fixed one size, I have fixed one index. So technically I will have to try for all possible indexes and for one index trying for all possible size. Now before we even proceed forward and try to deep dive, let's see is it even possible or not, because all possible indexes will take O of n complexity, and for each index trying for all possible sizes will take k because I can have k possible sizes. Let's see the constraints. Constraints: n is 1e5, k is at max 100, thus the complexity will be at max 1e7. it is just in the limits of 1 second. So I am good to go with the current approach. But making sure that anything inside this specific two for loops should be either a O of 1 operation or a O of log operation, not more than that. That's one thing. Again, log is also very unsafe, but trying O of 1 operation at max. Okay, that's one thing on in terms of how we approach any problem for contest. But again, this we don't approach. This is not how we approach in an interview. In an interview, we just simply proceed forward from here. So for one index, for a size of 3, for it to be a minimum element, I obviously know that, okay, if this is the minimum element, let's forget about maximum. If this is the minimum element, obviously that I know I have sorted it. I have sorted it. So all the elements higher than this are after him, right? If I know the current index is 7, the number of elements are 7, the current index is 2, which means I have already done I plus 1 number of elements. As you can see, 3 elements are already done. When I say done, I mean they are 3 elements are before this index, which means the remaining elements will be n minus I plus 1, which is in this case 7 minus I plus 1 is 2 plus 1, which is 7 minus 3 is 4. So this indicates I have 4 elements. Now, if I am saying the size of the subsequence is 3, size of the subsequence is 3, I have already chosen the minimum value. Thus, the candidates for the other two location are 4 candidates, which means out of these 4 candidates, I have to choose only 2. What is this 2? This is, if I remember, size. So 1 is already chosen, which is the minimum one. Remaining are size minus 1 candidates I have to choose. So it is nothing but out of 4 candidates, choose 2 candidates, which ultimately says that out of n minus I plus 1 candidates, choose size minus 1 candidates. This is when the current index I is contributing as a minimum element. Okay, now let's do the same thing for the maximum element. Okay, let's quickly copy this specific portion, and if I bring it down, I will simply realize that now the current one will act as a maximum element. Now, if it act as a maximum element, again the same stuff. I know the target was a size of 3. Now, out of 3, this is now acting as a maximum element. Still, I am remaining with size minus 1 elements, which I have to fill. How many candidates I have? Now I have I candidates. I is the index, but number of elements here will also be I. So candidates here is I. If I have I candidates, out of the I candidates, I have to choose size minus 1 candidates. It is nothing but I, out of I candidates, choose size minus 1 number of candidates. Now, because of this, these are the number of subsequences. Again, these are the number of subsequences where my this index I location, or I should say this specific nums of I will act as a maximum element. But is this what you require? No, I required that give me the sum of maximum and minimum elements for all subsequences. I have got the number of subsequences, but I wanted the sum. What is the sum? If I tell you that the number of subsequences where any element, let's say E, occurs as a max, is, let's say it is occurring 3 times. Obviously, the sum will be 3 into E, which means E is occurring 3 times. So it is 3 into E. Thus, for our case also, I can simply say number of subsequences for this index 2 element having a size of 3 as a subsequence for that specific index element occurring as a minimum element, number of subsequences are n minus I plus 1 c size minus 1, but the impact will be the element itself, which is nums of I, because I want to take the summation of elements itself, and same way I will multiply that nums of I here also. And this is for one index, for one size. I will do for this index for all possible sizes, and I will repeat this for all possible indexes also, and thus getting my final answer. Cool. Let's see the code. It's exactly as what I showed you. Now you know that I am dealing with nCr in this case. Now I'm dealing with nCr. For the folks who don't know what nCr is and how to compute it in the programmatic terms, please go and watch this video on to know that how we compute nCr, what is inverse modulo, how we compute nCr, what is factorial, inverse factorial, all that stuff. You can just go and watch this video, link in description. Coming on back, here you can see I have the modulo, simple modulo exponentiation. Then I have the pre-computation of factorial and inverse factorial. Again, if you don't know, just go and watch the above video. And then nCr, where I will use factorial, inverse factorial, and the corresponding, Fermat-Little theorem. Now, this is the actual crux which I mentioned, that I will firstly sort my nums. I will do the pre-computation of factorial and inverse factorial, which is used for my nCr. Then I will have the result. I will go on and try for all possible indexes. For each index, go and try for all possible sizes. For each index for one specific size, make sure to get the minimum contribution, which is n minus, this is n minus I plus 1 and size minus 1, nCr, and same way this is IC size minus 1. This is when the current element is giving the maximum contribution in its corresponding subsequence. And obviously I showed you that I will multiply by nums of I because I want the sum of element, and I'm simply adding that in my result and making sure that I'm doing mod at every step, because the problem itself asked me to do a modulo of 1 9 plus 7 at every step. And you can also see that I'm doing it, I have assigned a mod variable with the same value, ultimately giving the results. Because you are, using modular exponentiation and also you are sorting it, there's a time complexity be O of n log n for this specific case, but the main bottleneck is these two loops, which is n into k, and that is your biggest time complexity, or the biggest impact in the time complexity, which is time is O of n into k. And obviously space required, for your factorial and inverse factorial. As you can see, I have initialized my factorial and inverse factorial, the corresponding computation. When I did, I initialized this with the size n, thus I will be using a size of n in worst case, thus the space will be O of n. Cool. I hope you guys got it. Again, it is not that easy, but also not that hard, considering if you would have known that how to compute nCr, and if you would have watched, then it would have been easy to implement it, but thinking can still be tricky. And again, I'm a bit surprised that how many people were able to do it, because for many people, again, this is, I'm not just giving a blanket statement, but for many people the biggest challenge is math problem. But yeah, with this we will make it more easier, and yeah, practice more and you'll get it done. Bye bye, take care.